A hyperbola is the set of all points xy so that the difference in distances between the xy point and two fixed points, called foci, is a positive constant. So notice what happens as I move my point here. This distance here from F1 to the point P, xy, subtract this distance here from P to F2 is always the same length. So no matter where I move my xy point there, the subtraction always results in the same length or the same number. In other words, distance d2 subtract distance d1 is always a constant no matter where I move that xy point. Every hyperbola has two axes of symmetry. The transverse axis, highlighted in red below, is the line segment between the vertices. The conjugate axis is perpendicular to the transverse axis and is highlighted in blue below. The midpoint of the transverse axis is the center of the hyperbola. In this case, the center is the origin, the point 0, 0. Every hyperbola has two asymptotes that pass through its center. The two branches of the hyperbola approach the asymptotes, eventually becoming vanishingly close. The standard form of the equation of a hyperbola with the center at the origin. X squared divided by a squared subtract y squared divided by b squared equals 1. So here we have a and b are both positive. The foci are found by finding c squared equals a squared plus b squared, and the foci are plus or minus c. The y is 0. Vertices are the points plus or minus a and 0, and the asymptotes are y equals plus or minus b over a, x. When we have x squared first, this is a left-right hyperbola. The standard form of a hyperbola with the center at the origin, the equation is y squared over a squared minus x squared divided by b squared, all equals 1. A and b are both positive. The foci again, c squared equals a squared plus b squared, and of course the points are 0, plus or minus c. The vertices are the points x is 0, y is plus or minus a, and the asymptotes this time are y equals plus or minus a over b times x. The y term occurs first, so this is an up-down hyperbola. The example is graph y squared divided by 16 minus x squared divided by 9 equals 1. Because it's got a y squared and a subtraction of an x squared term, I know it's a hyperbola. So if I rewrote this, it would be y squared over 4 squared minus x squared over 3 squared equals 1. So that means a equals 4 and b equals 3. The center of this hyperbola, of course, is the origin. Asymptotes are two lines, y equals plus and minus a divided by b times x. So there's going to be two lines there. I know c squared equals a squared plus b squared. So that means c equals plus or minus the square root of 25. C is plus or minus 5. The vertices, because the y squared term is first, this is an up or down parabola, so the vertices will be 0 and plus or minus 4. The foci will be 0 and plus or minus c, which is 5. So I can graph y equals minus 4/3 x, and then graph y equals plus 4/3 x. I can put in my vertices, and then I can graph my parabola. And here's my foci. The more I zoom out, the closer the lines of the hyperbolas get to the asymptotes. Given the equation 25x squared minus 16y squared equals 400, graph the hyperbola, identify the center, the vertices, the foci, and the equations of the asymptotes. So I need to divide everything by 400 so that I can get a 1 on the right-hand side. So that's going to result in the equation x squared all over 16 minus y squared all over 25 equals 1. And I know the center of this hyperbola is the origin 0, 0. So c squared equals a squared plus b squared. So c squared is 16 plus 25. That's 41. So c equals plus or minus the square root of 41. Now, this is a horizontal hyperbola that opens left and right. The transverse axis runs along the x equals 0 axis because x is first. So the vertices will be plus or minus a, 0. So that is going to be plus or minus, well, a is 4, isn't it? Square root of 16 is 4, and b here is 5. So this is plus or minus 4, 0. The foci are plus or minus the square root of 41, 0. The square root of 41 is about 6.2 and some change. And the asymptotes, those two lines, they're going to be y equals b over a times x. So I have y equals plus or minus 5/4 x. So I'm going to start by plotting the two vertices, and then I'm going to plot the two asymptotes. Then I can draw in my hyperbola, and here's my two foci. The standard form of the equation of a hyperbola with a center at hk is given below. We replace x with x minus h, and we replace y with y minus k. So that's x minus h all squared divided by a squared minus y minus k all squared divided by b squared equals 1. The center is the point hk. The vertices are h plus or minus a and y equals k. For the foci, c squared equals a squared plus b squared. So the points of the foci are h plus or minus c, and then the y value is k. The asymptotes are the lines y equals plus or minus b over a, and we want to multiply by x minus h plus k. The transverse axis is horizontal, and the hyperbola opens left and right. Now we'll consider the case where the transverse axis is vertical because the y squared term is first, so the hyperbola opens up and down. The equation is y minus k all squared divided by a squared minus x minus h squared divided by b squared equals 1. The center is hk, vertices are h and then k plus or minus a. Foci, c squared equals a squared plus b squared, so the foci points are x is h and y is k plus or minus c, and the asymptotes this time are y equals plus or minus a over b times x minus h plus k. In the example we're given, y plus 1 all squared divided by 9, subtract x minus 3 all squared divided by 16 equals 1. So we're asked to graph the hyperbola, identify the center, vertices, foci, and the equations of the asymptotes. So the first thing I would do is rewrite the equations so I could understand what's going on. Since the y term is first, the transverse axis will be vertical. So that means it will open up and down. It's an up and down hyperbola. The center, I can just read off my rewritten graph. X is 3, so make sure you read or put x first. This is a mistake I see people make. They see y first and they write that first. Don't do that. So the center is 3, negative 1. A, of course, will equal 3, and B in this case is 4. The vertices are at the point 3 and then negative 1 plus or minus a. So I will have the point 3, negative 1 plus or minus 3. So the vertices will be the point x is 3 and y is negative 1 minus 3. So negative 4. And the point 3 and negative 1 plus 3 or 2. The foci will be at the point h, which is 3, and k, which is minus 1 plus or minus c. Now you remember that c squared equals a squared plus b squared. So in this case, c is going to be plus or minus 5. So we'll have 3, negative 6, and 3, 4. For the asymptotes, I'll have y minus k equals plus or minus a over b times x minus h. So this is going to be y plus 1 equals plus or minus 3/4 x minus 3. And by the time I solve each of those equations, so I'll have y equals minus 3/4 x minus 3 minus 1, and y equals positive 3/4 x minus 3 minus 1. So my two asymptotes will end up being y equals negative 3/4 x plus 5/4, and y equals positive 3/4 x minus 13/4. The center is the point 3, negative 1. vertices are 3, -4, and 3, 2, and the asymptotes are y equals -3/4 x plus 5/4 and y equals 3/4 x minus 13/4. So here is my hyperbola, and here are the two foci. And you can tell if I zoom out that the hyperbola gets vanishingly close to the asymptotes. In the example, we're given that 9x squared minus 4y squared minus 36x minus 40y minus 388 equals 0. We're asked to graph the hyperbola, identify the center, vertices, foci, and equations of the asymptotes. I'm going to have to complete the square twice. I'm going to group all the x's together, all the y's together. So that's going to give me 9x squared minus 36x minus 4y squared plus 40y, all in brackets, equals 388. Now I'm going to factor out the 9 and the 4, and I'll have to complete the square. So inside the parentheses for the x term, the coefficient of the x term is -4, so when I divide that by 2 and square it, I will get -2 all squared, or 4. So I need to add 4 and also subtract 4. It's just like adding 0. And then for the y term, I have 10 divided by 2 all squared. So that equals 5 squared, or 25. So I'll add 25 and also subtract 25. So I haven't changed the equation, I've just changed how it looks. Now I'm going to isolate the perfect squares. So that is 9 times x minus 4x plus 4 minus 4 multiplied by 9. Then I have minus 4y squared plus 10y plus 25 minus 25 multiplied by -4, and all of that equals 388. So rewriting this, I will have 9 times x minus 2 all squared minus 4 times y plus 5 all squared. So I have plus 100 minus 36. That's going to give me plus 64 equals 388. And that's going to equal 388. So I have 9x minus 2 all squared minus 4 y plus 5 all squared, subtract 64 from both sides, I will get 324. Now I still need to get an equals 1 on the right side of the equation. So that means I have to divide everything by 324. So that gives me x minus 2 squared divided by 36 minus y plus 5 squared divided by 81 equals 1, or x minus 2 squared divided by 6 squared minus y plus 5 squared divided by 9 squared equals 1, which of course means that a equals 6, b equals 9, and c squared is this plus or minus the square root of 36 plus 81, square root of 117. The center is the point 2 and -5. Since the x term is first, the transverse axis is horizontal, and this will open left and right. The vertices are 2 plus and minus 6 with a y value of -5. So that's -4, -5, and 8, -5. The foci are 2 plus and minus the square root of 117. The y value of -5. The asymptotes are y plus 5 equals plus or minus 9, 6 times x minus 2. So that's y equals plus or minus 3/2 x minus 2 minus 5. So we'll start with the center at 2, -5, and add the vertices -4, -5, and 8, -5. Then we can add our two asymptotes, our foci, and here's the graph of the hyperbola.